In the previous part of this lecture, we looked at the forces that move air from north to south or south to north. This motion was produced by the uneven heating of the earth by the sun, by the uneven heating of the air by the earth, and by the different weights of air, cold air being heavier than warm air. And as we saw, these forces together could move air from north to south or south to north. But what moves this air in an easterly or westerly direction? That's the subject of this part of the lecture. And the answer is the Coriolis force. The Coriolis force, which constitutes Rule 4 of our explanation of atmospheric physics, states that the rotation or spin of the Earth turns fluids on the Earth's surface to the right in the northern hemisphere and to the left in the southern hemisphere. We won't go into the scientific explanation of why this occurs because it's too complicated and would take us far afield. But just remember this rule. The rotation of the Earth turns fluids like air to the right in the northern hemisphere and to the left in the southern hemisphere. Let's now return to our slide showing the Earth in its vertical location. That is to say, the axis of the Earth running in a vertical direction. As this slide shows, the subtropical high at 30 degrees north and 30 degrees south push heavy cold air down to the surface of the Earth and drive air on the surface of the Earth both toward the north and toward the south in both northern and southern hemispheres. Thus, if you stand at 30 degrees north at the subtropical high, the air is moving away from you, both toward the equator and toward the pole. Let's take, for example, a person standing on the subtropical high in the northern hemisphere at 30 degrees north, looking south toward the equator. The air is moving away from this individual toward the equator, and the Coriolis force, as indicated, bends this air or turns this air to the right, which in this position would be from east to west, producing an easterly or what we call trade wind. Now, imagine that you are still standing at 30 degrees north latitude at the subtropical high, but you turn around 180 degrees and face toward the North Pole. Again, because of the high pressure zone at 30 degrees north, the air is moving away from you, northward, toward the pole. But again, the Coriolis force will bend this wind or air to the right, now from west to east, producing a westerly wind. The same logic occurs in the southern hemisphere, and the result is that between the subtropical highs at 30 degrees latitude, north or south, and the equator, the prevailing winds are from east to west, so-called easterly winds or trade winds, whereas the prevailing air flows from 30 degrees to 60 degrees latitude, again in both the northern and southern hemispheres, the prevailing wind is from west to east, or so-called westerlies. This slide shows us North America and reminds us that the United States is the continental United States, the lower 48, is located almost exclusively between 30 degrees and 50 degrees north latitude. As a consequence, the United States lies in the wake of the prevailing westerly winds. That is to say, the prevailing winds over North America and the United States in particular proceed from the west, from the Pacific Ocean, across the continent to the east or toward the Atlantic Ocean. And this produces our typical weather patterns, which proceed in this direction across the continent. If we were located south of the subtropical high, in what is Mexico and the Caribbean, the prevailing winds would be from east to west, or easterly winds, or what we commonly call trade winds. Now finally, let's summarize what we've learned so far. Basically, we've looked at the application of 4 rules: that the sun heats the earth unevenly, more near the equator and less near the poles. Secondly, that the sun heats the earth and the earth heats the air, also unevenly. Thirdly, that cold air is heavier than warm air. So where cold air builds up, we have high pressure zones pushing air toward the earth, whereas where we have warm air, we have light, low pressure zones and the air rises. And finally, the Coriolis force, the rotation or the spin of the earth, turn this air to the right or the left in the northern or southern hemispheres. These 4 rules explain global wind patterns and produce the prevailing easterly and westerly bands of wind above and below the equator. But the atmosphere also transfers moisture, or what we call precipitation. How does this work? We'll take up this subject in the next part of this lecture.